Welcome to the FabLite tutorial. I'm your FabLite expert John, and whether you're just checking out our software, just got your own brand new FabLite, or you're already experienced with FabCreator and want to see if there are any new tricks, this series is for you. In the last video, we showed you how to install FabCreator. In this video, we're going to show you how to import your drawings and process them for use on our FabLite machines. If you want to see more of this kind of content from us, give it a thumbs up to let us know it's useful, and subscribe to our channel as we release more tutorial videos. Have an idea for a video or want to see how something is done on FabCreator or on a FabLite? Let us know in the comments. Let's jump right in. This is our FabCreator window, and here we have our File toolbar and our View toolbar across the top. We'll work mainly in the left-hand tabs under the combo view, but first, let's open one of our files. We're going to open a .dwg file by clicking the Import button. Here, you're able to select .dxfs, .dwgs, and soon you'll be able to open .step files. We'll release a new tutorial when that feature is ready. You can also open .fab files that you've already created by clicking the Open button, or you can also find both of these actions under the File drop-down menu. Let's open this demo bracket file, which you can also find on the same page you found the software and database files for download. Under the combo view, a few of our tabs are now accessible. We have a Part, Edit, Properties, Process, and Job tab. The last two tabs become clickable once we get to the Properties tab. The workflow for processing parts follows these tabs from left to right to make it easy for you to keep track of where you're at. We'll start with the Process tab. Undoubtedly, the most important tab of the 5 to make sure your parts come out the way you want them to. Here, you'll find a folder. Expanding this folder by clicking on the arrow to the left will show you 4 process folders: Cut, Engrave, Raster, and Reference. Further expanding each of these folders, you'll also find all of your geometry for your imported drawing. In your main drawing window, your geometry is colored depending on the process you have chosen for it. If you are using a drafting or graphic design software that allows you to place geometry in different layers, as we did for this file, you can create a cut, engrave, raster, and reference layer that will automatically place this geometry in the process folder you desire. If you're not using drafting software or forget to place the geometry into the different layers, don't worry. All of your geometry will end up in the cut folder. When you import drawings into FabCreator, you don't have to tell the software which geometry is the outermost shape. We use island detection to determine which geometry should be cut first, so you don't have to. The order of the shapes does matter in these folders, most importantly, the cut folder. This order determines which geometry or shape is cut first. So, if we click the first shape in our geometry tree, we see it highlighted in yellow. We can follow the cut order by selecting each of the following shapes until we end up at the outermost geometry to be cut. When importing a drawing into FabCreator, the software also intelligently places the order of these shapes with the most optimized path in mind to save you as much time as possible. However, if you need to cut a particular geometry before another for whatever reason, you can simply do that by clicking on the shape you'd like to cut first and dragging it to the shape you'd like to move it above. Of course, you can always undo and redo these moves by clicking on these buttons or pressing Ctrl-Z or Ctrl-Y. You can also change the type of process you want to apply to a shape. Simply click the shape you'd like to change in the geometry tree, or click on it in the geometry window and see it highlighted in the tree. Once you've selected the shape, either drag and drop it to the process folder or right-click and select the process you want to change it to. You can also press Shift-B and left-click in your geometry window to select multiple geometries. Once you've got everything where you want it, you can now move to the Edit tab. Here, we can modify our parts by moving them or rotating them. Simply click Move/Rotate Part and a new dialog will appear. Then, click on your part so that it is highlighted in white. Your move options will now be accessible. Note, we can't move individual geometries in FabCreator. To do that, you'll need to go back to your original drafting program and make changes there. Quick tip, the grid in the background represents the bed of your FabLite machine that measures 25 inches by 50 inches, and each square of the grid shown here is 1 square inch, making it a little easier to visualize your parts. Once our part has been selected, you can either enter the distance you'd like to move it in the X or the Y direction, or you can click the arrows to move it in increments. You can also quickly move it back to the origin by clicking Move Part to Origin. You can also rotate your part by entering the amount of degrees you'd like to rotate it, or you can click the clockwise or counterclockwise rotation buttons to move it in increments of 90 degrees. Click OK to confirm your changes. You can also move your part and reference it to the origin by clicking Move to Origin. Here, you can move it completely to the bottom left corner, or you can have your part aligned to either the X or the Y axis. You can also delete parts. Typically, you would only use this if you've imported multiple drawings into one project. And lastly, you can edit text. If it's recognized by FabCreator from your drafting software, you can click Text and select the text you would like to modify. Here, you can change the font, the size, and the content quickly and easily. Next, we can move on to the Properties tab. Here is the second most important tab, where you're going to select the material you'd like to cut. First, we want to make sure you're using the correct database, so check here to make sure the database listed is the one that matches your machine. After that, you'll select what kind of part it is that you're going to be cutting. Here, we can select sheet or tube. We're going to select sheet for now, but in the next tutorial, we'll show you how to process your parts for tubes as well. Then, we need to select what exactly we want to cut. We have a standard database that has aluminum, steel, stainless steel, copper, and more. As a reminder, we are doing process development for materials all the time for our customers. We're constantly growing this list, but if there is a metal material you don't see in the database, reach out to us. Chances are we have a process for it that needs more development, or we'd be happy to start some development for you. Next, we're going to move on to the thickness of the material you want to cut. Same here, our database is always growing, so if there is a thickness here you don't see, reach out to us. We typically leave the auto sheet size selection on, but if you need to specify a sheet size, you can do that by deselecting that option and entering your dimensions. We also typically leave the engrave and raster settings as default. For the raster settings, you may find the default fill settings to be unsuitable for your application. You can make adjustments to the DPI or dots per inch here, but note that this may take some back and forth testing to fine-tune the amount of raster you'd like to see, and the time it takes to raster a part will also increase. Once you've confirmed all your settings, you can click Accept, and your final 2 tabs will be accessible. Clicking on the Process tab, we see a couple of options and one new one that we're working on for our customers. The most important option here is the Tabs button. Clicking this will bring up our tabs editing mode, where you can specify the length of a tab. For those that are new to laser cutting, a tab is a small amount of material that is left uncut in your selected geometry that is created to hold parts in place during the cutting process. Tabs are a great way to make sure that your parts come out the way you intended and makes it easy to collect your parts out of the easy load drawer. You may not want to add a tab because you don't want to do extra finishing operations on your part, and that's fine. Just note that your parts may fall or partially fall during the cut process. Here, we can define our tab length, which we typically set to 5/1000ths of an inch. We can insert tabs, move tabs, and delete tabs. We can also delete all of the tabs if we desire. We'll need to click Done to make sure our tabs are set. Now, we return back to the main Process tab window, but in our Geometry window, you may notice a white outline around your parts. If we zoom in, we can see that this is our kerf compensation. Again, this is left on by default, and the default value is 5/1000ths of an inch. The white outline that we see around our parts is the toolpath, and the difference between our original shape and the toolpath line is half the diameter of our kerf, which is 2.5 thousandths of an inch. We can also see where the tabs are being created. The toolpath has a break, which represents the tab being created there. A new feature that we're experimenting with is lead-ins. A lead-in line is a feature that starts the cut line a specified length away from your actual part. This can be really great for keeping the surface of your parts clean and unaffected during the cutting process. We can create lead-ins the same way we create tabs by clicking on the geometry we want to add a lead-in to. While not currently accessible, we will be releasing this feature soon, so make sure to keep an eye out for the update. Finally, we can come to our job window. Here, we can preview our file, see the slews, and step and repeat. Step and repeat is a great way to save time cutting multiple parts without actually importing multiple drawings. Our step and repeat function will not do automatic nesting though, so if you need to have nesting done, we recommend using your own drafting or nesting software. There are some free open source nesting software out there like deepnest.io that are a great alternative. If we select step and repeat, the rest of this dialog box becomes available to us. The part size is calculated based on the geometry we've already provided. The first way to perform the step and repeat function is by selecting Auto Fill Sheet. If we use this option, we can input the sheet size we'd like to fill, and FabCreator will automatically fill this sheet with as many parts as possible that account for the gap or offset and minimum border we've input. We can also deselect Auto Fill Sheet and specify a certain amount of parts in the X direction and another amount of parts in the Y direction. For example, we can do 50 parts in the X and the Y directions, and if we click Apply, you can see that FabCreator will automatically adjust our counts in each direction to fit that dimension. We can separate the parts either by an offset or by a gap, and we can set both of these in either the X or the Y direction. Finally, specify the minimum border around your part, and then select Apply. Once applied, you'll see a set of empty white outline boxes that represent the repeated parts. If you want to see a full job preview, you can do that by clicking Show Job Preview at the top. Depending on the complexity of the original part, it can take a little bit for this to process. In addition, you may want to show slews. Slews are the overall toolpath for the job and the steps it takes to work through your project. It can be helpful to check this if you're having an issue with your job. Finally, we can see the job information. This is a great place to confirm your material type and thickness, the number of parts you're cutting if it's a step and repeat, your part size, and your sheet size. In addition, a job time will populate here. This is typically an overestimate of your job by anywhere from 20 to 10%. True job times can be found on the display of your FabLite during the actual cut. And that's it. You can click Make and Save to create a .fab file that you can bring over to your FabLite machine. To recap, you can drag and drop or select shapes and right-click to determine what process you'd like to apply to that geometry. The order of the geometry in the cut folder determines the cut order from top to bottom, and the last geometry should be the outermost edge of your part. The Properties tab is important for your cuts, but if you don't see the material you want to cut, reach out to us. Tabs take only a couple of clicks, and step and repeat can save you time quickly and easily. Watch our next video where we'll show you how to process tube files for cutting on your FabLite machine. Remember, cut right, cut with FabLite.